Hello mathematicians, puzzlers, and other curious people. I had tried to make this video yesterday, but some of my software acted up and the sound was just completely missing. I don't know what went wrong. I ended up just giving up on troubleshooting and reinstalling it and starting over. I've done a little sound check, so this should be working today, knock wood. Here, this paper napkin that I got with some takeout used to be wood. So the problem that we are looking at today is, and this is one that was sent to me from a possible student at Wysant. They didn't get back to me about scheduling a session. I don't know if they figured it out or what, but it's an interesting problem, so I wanted to go ahead and kick it around for whoever would like to see it. So we're given the problem that the quadratic function f has the equation y equals x plus 2 squared. So we have this to start with, that f of x follows the equation y equals x plus 2 squared. Now, just to be clear, x plus 2 was in parentheses in the problem statement. So we're taking x, adding 2, and then squaring that, not taking x and then adding 2 squared because we could just simplify that to 4 for one thing. It would just be senseless to write it that way. Okay, so the next thing we're asked to find out is with which factor. So I'm going to name that factor. I'm not going to name it f because that would get confusing. I'm just going to name it a for reasons that will be convenient later on in the problem. With which factor a do you have to stretch the graph of f in the direction of the y-axis so that the graph of the new function f1 intersects the y-axis at point P, which is 0, 1. So we've got a parabola, and we're talking about stretching it vertically with the y-axis. So what that's going to do basically is, well, if this point here, say, is stretched up by a factor of 2, then that'll be twice as high up. Similarly, all over, allowing for sketching error, of course. So we're talking about a constant factor being applied to the whole thing. So one thing we can say here is that our new function that we're trying to come up with, f1 of x, will be some factor a times f of x, where, again, a is just some element of the set of all real numbers. So it's just some number. We don't even know what number it is yet. Okay, so with which factor? So this is what we're trying to find out. So we want to know, common abbreviation, want to know, a specific value of a, that meets certain requirements. Let's see, that was in this. Okay, so that the graph of the new function f1 intersects the y-axis at the point 0, 1. So here's our other specification, that f1 of 0, again, we're talking about intersecting the y-axis, equals 1. In other words, 0, 1 is a solution to the equation f1. Okay, so let's investigate what we can do about this. So I always like to start by saying, okay, what happens? So we've got x and f of x, and I'm seeing that that if we just try out our basic 5 points that are a good place to start investigating, we can say, okay, negative 2, well, plug that in. So negative 2 plus 2, well, that's 0. 0 squared is 0. Okay, so that was pretty straightforward. We can go ahead and continue it. Let's see, negative 1 plus 2 is 1. Squared is just 1. Let's see, 0 plus 2 is 2, and then 2 squared is 4. I'm specifically not going on from here and then saying 2 squared is 4, because then I'd be saying that 0 plus 2 equals 4, which would not be true. So when I'm taking something and plugging it into sort of doing a further problem on it, I just copy it over on the line below and then go on writing my next problem from there. I mean, that's not the only way I ever organize it, but it works. Okay, let's see. 1 and 2 is 3. 3 squared is 9. 2 and 2 is 4. 4 squared is 16. Okay, pretty straightforward. Now I notice that there's something that's not quite showing up on this graph, or if we make a graph of it, that is. So I'm not going to go all the way up to 16 because that would not be very enlightening. That's not really the most important part of it. But I am going to say, okay, we've got negative 2, 0, negative 1, 1. Let's see, 0, 4, 1, 9, 3, let's see, 3, 5, 6, 7, 8. Okay, I'm just going to, so 9 would be up there, but I'm just going to ignore that because that's going to get messy. But we can see from this that we've got an increasing and accelerating, in fact, function here. And allowing for sketching error, it does more or less this. I'm not quite happy with that curve there. I'm going to fix it. Okay, still not perfect, but it's good enough to illustrate what we're doing. Now, I wanted to come up with a function. Let's see, where was it? Okay, so that was f of x. Now, I wanted to come up with a function f1 of x that would go through this point right here. Now, I notice that this point 0, 1 is 1/4 as high as this point 0, 4. So really, the most important piece of information that we've got right now for coming up with our next function is this point right here, 0, 4. Well, I notice that if we want f1 to be something times f of x, well, we need that something to be 1/4, because then we'd say, okay, 1/4 times f of x, well, right here, f of x would be 4. So that would give us 1, like we want. So then let's see, if it's 1/4 of the way down, let's see, that 9 times 1/4. Let's see, 8 times a fourth would be 2, so 2 and a fourth. Putting a plus sign in the middle of a mixed number is a good way to deal with it because it helps you clear up whether you mean that to be multiplication or a mixed number, by the way. But if it's in the middle of other operations, it can also be really useful to put that in parentheses. Okay, so let's see, 2 and 1/4. Whoops, let's see, yeah. 1, 2 and a fourth. So right there, 0 times a fourth is still 0. So that gives us an idea of what f1 of x would look like. So it's kind of that same shape, increasing and accelerating, but much more slowly than the other. Now there's something you might have noticed, and that's that we don't have the whole parabola here. So here's what I mean by that, and I'm going to tidy this up just a little bit, take off some of our scratch work. Okay, so you may have expected, when you noticed that this clearly had the parent function f squared, I'm going to call that p of x squared, and just change my mind about the color. I'm going to make sure that this doesn't get confusing, I'm going to make this one red. So x squared we're all familiar with, right? 0, 0, let's see. So 0 squared is 0, 1 squared is 1, negative 1 squared is also 1, 2 squared is 4, negative 2 squared is also 4. And so you may have noticed that we could have used that parent function to find out some information. So we can see that our original function, f of x, is traveling upward in very much the same way that that parent function did. Oh, my mistake. I miscounted. Let me fix that. I've got a point here at 2, 3. I'm going to put it up at 2, 4 where it belongs. And yeah, I goofed up by symmetry too, so I'm just going to fix both. It's no big deal. These things happen. That's what's nice about whiteboards. They're easy to fix. Whether it's on a computer or an actual, physical whiteboard. Okay, again, allowing for sketching error as far as the curve wobbling a little bit through here and through there, but it doesn't have to be perfect. It has to show the right information. And now let's see, over 2, up 4, there we go. Okay, where was I? Okay, so we've got this nice parabola shape in our parent function. We don't have that whole parabola shape showing up here. So one thing you can notice is that our original function f of x is doing its thing 2 units over from f of x. Now this is the part that gets tricky. You can see that in this formula, but people get this backwards a lot. So when you've got this x plus 2 right here, what people think is, okay, well, it should be over here and then there and then there, etc. And clearly that's in the wrong direction. So one thing that can be convenient for remembering which way to go is it's kind of like f of x is looking in a positive direction by 2 units at its parent function p of x to see what it should be doing. So if we kind of continue that, we notice that this here should be the vertex of f of x, and it's a little tricky to see where they intersect, but p of x had a point right there. So f of x should have a point right there. We can check this. So I'm just going to make a little more room. So if we look at negative 3, well, let's see, negative 3 plus 2 is negative 1. Negative 1 squared is 1, just like we could predict from the parent function behavior. By the way, if you're doing this in a calculator, make sure you get those parentheses around the negative 1, because if you just punch in negative 1 squared, your calculator's going to say, okay, well, that's kind of like 0 minus 1 squared, and then I should do that exponent first, so it's going to say 0 minus 1, okay, negative 1. So your calculator is going to do its best to guess what you mean, but it's going to be wrong. So you're really going to get a better result if you make sure to use parentheses so your calculator doesn't have to guess. Let's see what else happens. So I noticed we had a point here on our parent function. Well, then we should have a point here on f of x. And now what good does that do us? Because what we really wanted to find out about was f1 of x, this blue function. Well, if we have a point here on f of x, we would expect that a quarter of the way up, we would have a point on p of x. And if we have a point here at, let's see, negative 2, 4, well, a quarter of the way up, that would be negative 2, 1. You might notice that it's giving that same symmetry effect. So if you sketch in, I'm going to use green for this because it applies to 2 of them. If you sketch in an axis of symmetry, you can clearly see that that we have like 2 units over and then 2 units over again. We can reach the same function in 2 different directions. So it's reflecting. So we see that this function has, the behavior of a parabola as far as symmetry goes. But one thing we wanted was an actual formula for f1 of x. So let's see where we can go from there. So now we know the value of a. So we know that f1 of x is 1/4 times f of x. Well, f of x was just x plus 2 squared. Now, there's a few different ways you can deal with this. One way is you can say, okay, I noticed that we've got a binomial being squared, so we can use a perfect square trinomial formula for that. But if you don't happen to remember that formula, another thing you can fall back on is, well, it's just a binomial times another binomial that happens to be the same one. So now we could just FOIL this out. So we could say, okay, x squared, outer, inner, so 2x and 2x make 4x plus 4. So what I see here is what we are looking at is 1/4 of x squared plus 4x plus 4. And then we can distribute that 1/4. So we would have 1/4 x squared plus, well, 1/4 times 4 is just 1. So plus x for that term. And then plus 1 for the next term. Now, as far as if it's a homework question, as the case was in this particular one, what's a good final answer? Well, this right here is one good option for a final answer because it clearly shows how you come up with the whole thing. This here is really more of a step, maybe an important step, but I wouldn't put it for a final answer. This here could also be a final answer, depending on what your teacher's looking for. Unless you know that your teacher wants something different, I would just put both because it's always a good idea to be thorough. Let's see. Now, I want to just point out how it wasn't a coincidence that I used a for my factor here. So I noticed that this was going to be a quadratic equation or a quadratic formula. And if you remember a little bit about quadratics, you might remember that they're often written in the form ax squared plus bx plus c. Well, in this case, a is in fact that factor that we had come up with. Let's see, b is 1 and c is also 1. So depending on other things you might want to find out about that same quadratic formula, you might use some other things based on quadratics. But that those sorts out what this problem was asking for. Let's see. Okay, so that's where I'm going to leave off in this problem. So I hope that that it was an interesting problem to work on. If you've got any other graphing and stretching types of problems, see if any of these tricks help you out with that. And feel free to drop me questions. And if you've got a question that you would like me to tutor you on, feel free to click through from Math with Avrila onto my Wyzant tutoring, and we can get something scheduled that way. And other than that, calc you later.